Uh, Good evening, everyone. Okay. So we are discussing about ping, DOS, and a lot of different types of tax network protocols. We have discussed a lot of different things. Coming to network security. Network security, when it comes to network, we have different aspects like this. So network, as you all know, it has got a lot of different resources. Say we got computers, and all these computers connected to a switch, to a device called switch. Switch could connect. Then we have routers, then we have firewalls. So this is your local area network, which is LAN. So we have our LAN. So in this internship of network and network security, what we have discussed is this: how we can connect computers to a switch, how we can connect a switch to a router, and how the configurations can be done, what kind of cables are used, what kind of configuration is done in a switch, what kind of configuration is done in a router, and different things like this. And we have discussed about basics of what DOS attack is, which can happen inside a network. And the other different types of attacks, what can happen inside a network is you can speak about sniffing. That is network sniffing, which can happen inside a network. Means this is an attacker here, and assuming this to be a Wi-Fi modem. This to be a Wi-Fi modem, and this is a free Wi-Fi. A free Wi-Fi, and a lot of different, you say 100 users are connected to this free Wi-Fi, and sniffing becomes one of the most important aspect of an attack for a LAN. What do you mean by sniffing? This is an attacker here. He is connected to this Wi-Fi, and he is able to view what others are doing, which website they are accessing, and what credentials they are entering, different things like that. So basically what he is trying to do is he is trying to grab the packets of all these computers. He is accessing all these packets, and he is analyzing all these packets, and he is finding out a lot of interesting facts about the traffic. So sniffing is one part of an attack which can happen. Again, apart from sniffing, you can speak about phishing based attacks that can happen. So now all these attacks, they are mainly focusing on what? They're mainly focusing on the traffic of the network. So when it comes to network security, the first and predominant one which we should be concentrating on is network traffic. So we'll look into different tools which can help us in capturing this network traffic, and how we are going to analyze all these packets. And the number one tool for traffic analysis, what we have here is we have Wireshark. So Wireshark is a tool which can be used to analyze a lot of different traffic here, to capture the traffic. And since we have discussed about computer communication, you all know how computer communication happens. Computer communication happens in the form of what? Packets. And I told computer communication happens in the form of packets, and all these packets are like courier packets which are sent from one device to another device. And this packet has got a lot of interesting information, but we have never seen this with our eyes. We have never seen these packets going out of your computer or entering your computer. So we have this tool which is called as Wireshark, which is going to help you in analyzing the incoming and outgoing traffic of your computer. So this tool is called Wireshark, which is a basic tool. In corporates, you have traffic analyst designations. Wireshark analyst, you have specific designations for this tool. It's quite an intense tool what you have here. So it will analyze incoming and outgoing packets of your computer. It's going to analyze incoming and outgoing packets of your computer. So it's going to capture and analyze incoming and outgoing traffic of your computer. So when I say it is going to capture, it's like a CCTV camera. CCTV camera, it will show you what is happening. But with this, you can't prevent any attacks from happening. With the help of CCTV camera, you can resolve or you can trace back what has happened, but you cannot stop any attacks. With that in place, we look at this tool called Wireshark. You will have to install this tool in Windows. Kali Linux, yes, we have Wireshark inbuilt in Kali Linux, but it is better if you go for Windows. So we have download here Wireshark, and let me open this Wireshark. So when I open this tool, this is a landing page of this tool called Wireshark. And Wireshark, we'll have to tell Wireshark from which interface we'll have to capture the traffic. So this is happening in my computer. This is my system, which is Windows, and I've installed Wireshark here. Now, for this particular system here, I can receive internet connection in two different ways. What are the two different ways? This is a Wi-Fi modem here. Wi-Fi modem, what we have here, and my computer, it can get a wireless connection like this from this Wi-Fi modem, or this can be a wired connection just like this. If it is Wi-Fi, I'll name it as WLAN 0. If it is wired connection, that's going to be ETH 0. So I have two different types of connections for my internet. Now I have to tell my Wireshark from which interface it is receiving traffic and from which interface we'll have to capture the traffic. So for my computer, it is going to be what? It is going to be Prom Pentest 5G. This is Prom Pentest 5G. So I'm going to choose what? I'm going to choose wireless LAN. Wireless LAN. In case if it is a wired connection, I'll be choosing ETH 0, Ethernet connection. So when you look at this, you can see here, we have Wi-Fi, and you can see some traffic here. And for Ethernet, we have very little traffic and loopback traffic, leave all those. We know that this is going to be Wi-Fi. So when I double click on this, what's going to happen is it's going to capture a lot of different traffic here. When you look at all these traffic, Wireshark is capturing a lot of different traffic here. And now Wireshark is not responding. Why? Because it has got a lot of different traffic packets to be captured. Now tell me, I didn't open any browser. I've not opened any browser. I've not used any application, but still Wireshark is capturing a lot of traffic. What traffic is this? When you look at this, see, this is the time zone. This is the source IP address, the destination, and this is the protocol here, and length of the packets, a lot of different things. And if you see this, observe this is UDP. And we have a lot of packets for UDP. Why? Because Zoom meeting is happening in the background, and it is capturing a lot of packets for UDP. And each of these packets, as I've said, it's like a courier packet. We can analyze any of these packets here. To analyze all these packets, see within like fraction of 3 seconds, how much packet it has captured. It has captured, when you scroll this down, it has captured more than 16,288 packets within a matter of like 2-3 seconds. I've just turned it on and I've turned it off. So you can use the above options here. Say this option here is for going to the first packet. It goes to the first packet. And this option here is for the last packet. But still, when you want to scroll down and look into a lot of different packets, it is going to be very tough. 16,000 packets, and it is going to be tough for you to scroll down all the way down and scroll back all the way up. So we'll be using filter commands. I'll tell you what filter commands are. Now, when you look at any of these packets, let me choose this particular packet here. Now, what is the IP address of my computer? IP address of my computer is this IP config. My computer's IP address is 192.168.1.101. 1.101 is the IP address of my computer. Now, what happens is, if you look at the source IP address, text is small here. This is source IP address, and this is destination IP address. So this packet has gone out of my computer. I'll explain this in brief. My system and the IP address of my system is 192.168.1.101. I'm running Wireshark in my computer, and I'm contacting, I don't know which server is that, but that's a different IP address. So when Wireshark captures the packet which goes out of my computer, when a packet goes out of my computer, and if you observe this packet in Wireshark, if you look at this packet in Wireshark, the from address will be, let's assume this is 21.10.2.3. What will be the from address of the packet when it goes out of my computer? From IP address 192.168.1.101. The to address will be obviously 21.10.2.3. Yes. And when this server replies back, and when my computer receives the packet, now when Wireshark looks at this packet, what will be the from address? From address is 21.10.2.3. What will be the to address? 192.168.1.101. That is the reason you are able to see my IP address, which is 192.168.1.101 in the destination address and also in the source address. In both these places, you are able to see my IP address because these are the packets which my computers have sent and which my computer has received. Yes, I'll just make one little configuration to this Wireshark. Just let me close this without saving. We go to Wireshark. Wireshark properties. Okay. Now let me open this Wireshark to check if it's still there. Okay, I hope now you are able to see the source IP address and the destination IP address here. This is the source IP address column. This is the destination IP address. And this is the protocol length and information. And as I said, I have TCP packets. Oh my God, still running. I have TCP packets. I have UDP packets. And now there are different ways with which you can analyze all these packets. I hope you know what OSA layers mean. What do you mean by OSA layers? OSA layers. Yes, that is abbreviation of OSA. Now, what is OSA? Yes, how packets are transmitted from one computer to another computer. What different transformations happens for these packets when it goes from a sender to a receiver. That's explained in OSA. Layers, yes, different layers. We have different layers. Say we have physical layer. Physical, what is the next layer? Data link. Can you see OSA layers with your eyes? Yes, we can. We can see the devices which are present. Transport, what is the next layer? Session. Sessions layer. What is the next layer? Presentation. We have presentation. And then we have application layer. So we have different layers like this. And these layers, they are called as L1, L2, L3, layer 1, layer 2, layer 3. In corporates, designations will be like this. If you say he is an L2 support engineer, which means he is working with the data link layer. L3 engineer, which means he is working in network layer. Fine. And we have different devices to be in place. Physical layer, you can call it as you can have hub at this place, or data link layer, you can have switch. Network layer, we have router. Transport layer, we have cables, and all others happens inside computer. Now the function of all these layers shortly, when I have a data like the 0, 110, 110, I hope everyone knows in computers, everything is zeros and ones. From this layer to the next layer. When it goes to switch, what is the function of a switch? Function of a switch is MAC addressing, packet forwarding and MAC addressing. So it adds what? It adds source MAC address and it adds destination MAC address. It goes to the next layer. It goes to router. Now, what is the function of a router? Function of a router is IP addressing. So we already have MAC address, source and destination here. Now we will have source IP address and source MAC address. Now it goes to transport layer. What is the function of transport layer? Transport layer function is flow control and error control. So now what happens? What gets added in transport layer? We have TCP header to be added. TCP header. Now, what is there in TCP header? You will have source port number, you will have destination port number, you will have sequence number, you will have acknowledgement number, you will have checksum, you will have different aspects like this which is getting added. And after this, it becomes data. Data, data, and data. And the function of sessions layer is authentication. What do you mean by authentication? Where if the username and password, what you give, gets validated in sessions layer. Get the validate out. Presentation. Presentation layer involves with what? Involves with encryption and decryption of the data. Application layer, it uses any sort of application, either inbuilt or third-party application. Very simply, in simple terms, you are sending a JPEG image, 1.jpg from your computer using Microsoft Office. And the recipient is opening the same 1.jpg image using Liber software or some other tool, but he gets the exact same JPEG image. That happens with the help of application layer. Now, what OSA layer does, it helps in looking at the details of all these layers. So in case if I need username and password, which layer I have to look into? Sessions layer. Yes, I'll have to look into sessions layer. Let us go here and analyze this and check if this happens or not. Wireshark. What? Wireshark. Wireshark, I think it was capturing traffic till now. We'll close this. I think we can open this packet here. Okay. So traffic like this. Now, what I'm going to do here is I'm going to double click on this, double click on any of the packet. And if you look at this is what? The layer, what you see here, the first one, frame. That is your, which layer? Physical layer. Second layer, Ethernet. That is your data link layer. Data link layer, what device we have? We have a switch. And switch functionality is MAC address. Source MAC address and destination MAC address is getting added. Then we have network layer where we have router and we have source IP address and the destination IP address to be added. Yes. And the last layer is what? Like the transport layer. And when you look at the transport layer, we have TCP header where you have source port number, destination port number, sequence number, acknowledgement number, checksum. You have a lot of different things, right? So when you're analyzing a packet, you can analyze like this. Now, this is one such packet which we have analyzed. Now, what is the continuation of this packet? After this, is it this packet or is it this packet or is it this packet? We are not very sure because in a tab which you have opened multiple tabs. You have opened multiple connections. So to look into a particular connection, right click and you can say follow TCP stream. If it is UDP, you can right click and say follow UDP stream. When I click follow TCP stream, I don't get anything for this. Let us close this. Let us clear the filter. We'll go for another packet here. Right click, follow TCP stream. Now, when you look at this, see this, we have the information, what is being transferred, and red color. Listen to this carefully. Red color, which indicates packets which went out of your computer. Purple is the reply which your computer has got. Red is packets which went out of your computer. Purple is the reply which you have got. So we can segregate packets like this. Now, what we can do is we'll try to use filter commands. When you look at this top place, you have filter commands here. Yes. Now, assuming my computer's IP address to be 192.168. What is my computer's IP address? Okay. My computer's IP address is, say, for example, 192.168.1.2. This is my computer's IP address. So my computer IP is 192.168.1.2. 1.2 is my computer's IP address. In case, when it comes to filter commands, we can go like this. If you want to see packets which your computer has sent, the filter command, what I'm going to type is IP.src, that is source, equal to 190.168.1.2. Yes, when I type this IP dot, I'm typing here, I see the color has turned pink, which means either the syntax is wrong or the syntax is incomplete. So I'll have to complete this IP.src equal to 192.168.1.2. Now it says, now it turns green, which means the syntax is right and the syntax is complete. Enter. Okay, let me clear this and then type the same command, IP.src equal to 192.168.1.2. Enter. Now we look at this. These are the packets which went out of my computer. If you look at the source IP address, it has changed to 192.168.1.2. So these packets went out of my computer. Now, in case you wanted to see which packets are received by your computer, to see packets received by your computer, then we'll have to type what? Destination equal to 190.168.1.2. Yes, as simple as it is. Now, to see packets sent and received only by your computer, you can type IP.addr equal to 190.168.1.2. When you give this, only your computer's packet will be visible and not any other computer's packet. Now, to see HTTP request, which is get and post, you can type something like this, http.request.method. When you type http.request.method, you are going to see only HTTP packets exchanged between your computer and the server. So these are few filter commands which you can use, and we can also go for very basic filter commands like this. I want only TCP packets, type TCP, enter, you'll get only TCP packets. You want UDP packets, type UDP. In case if any UDP packets are there, you'll get only UDP packets. So filter commands plays a very vital role in accessing Wireshark. Why? I'll tell you this example. In corporates, how they are going to use Wireshark is something like this, where it's still capturing this. This is still capturing. Perfect. In corporates where they have in their LAN, where they have 100 computers, where they have a lot of different computers here, and obviously they'll have a server, and all the traffic of all these computers will pass through this server. So any configuration which you want to make when your LAN has like 400 to a large number of computers like this, you cannot make individual configuration on all these devices. Instead, you will make configuration to the server. Any configuration which you make to the server will get applied to what? Will get applied to all these computers. Yes. So rather than running Wireshark in all these computers individually, what I can do is I can run Wireshark in the server, just like a CCTV camera. So I'll be running Wireshark in the server. And now what happens is, when you look at the size of this Wireshark, it can be 10 gigs of data. It can be 20 gigs of data. The size of one Wireshark file can be as huge as like this. So when you want to analyze like 8 lakh packets, 2 billion packets, obviously we need filter commands, which will be very easy for you to segregate all these packets. And the output of all these Wireshark files is called PCAP. The extension is called PCAP. PCAP stands for packet, and this stands for capture. Packet capture. So if you see any file name, the extension called .pcap, .pcap-ng, then that's an output file of what? Output file of Wireshark. Yes. So going back here, this is one way of analyzing the packet, where you can either double click the packet and look at the contents of this packet like this, or in case you want to look into the continuation of the packet, I can right click on this packet, follow and TCP stream. In case if it is a UDP packet, I can right click on this and I can follow. It says UDP stream. I can follow this UDP stream and you can see what contents are there. You got this? So this is basics of what you can do with Wireshark. Now, what we are going to do here is this. First is we are going to check. What we are going to check is we are going to analyze or we are going to capture three-way handshake. Three-way handshake. What do you mean by three-way handshake? Initial communication mechanism which happens between my computer and any other server which I'm trying to connect. The first packet which goes out of my computer is SYN. I'll be getting a SYNAC and finally I'll be sending an acknowledge. This we have seen theoretically, but practically we have not seen this. So now what we'll try to do is we'll try to connect to the server and we'll turn on Wireshark. So this is what we are going to do here. We are going to connect to a website. Say this is, for example, this is abc.com. abc.com is the website to which I'm going to connect. Yes. And I'm going to open this in my browser. I'm going to type abc.com. And in case if I open, TCP three-way handshake happens in the background. But now I wanted to check whether this, I wanted to capture this TCP three-way handshake with the help of Wireshark. So what I'm going to do here is, first, I'll turn on my Wireshark. As I said, it's like a CCTV camera. It has to be on. Only then can capture packets. So first we'll turn on Wireshark. And after that, go to your website, go to your browser, visit this. And after that, Wireshark will have a lot of packets. And for this instance, it can have more than 25,000 packets. As we have seen now, it is capturing a lot of different packets. And third, what we'll have to do is this. We'll have to, this is number 1, this is number 2, and number 3 is we'll have to use filter command. Filter command to filter out what? To filter out the traffic between my computer here and abc.com. And my computer's IP address is 192.168.1.101. And abc.com's IP address is, for example, this is the IP address. Now, what will be the filter command which I can use? It's very obvious. I cannot use a filter command like this ip.addr equal to. If I use the IP address of my computer, will I get the exact result? No. Why? Because ADDR. So it will show me all the packets sent and received from my computer. 25,000 will still be there. So what I can do is, instead of doing this, I'll give the destination server's IP address. So I'll say 82.10.2.1. Yes. As simple as it is. And those packets will be filtered out. And when I scroll to the first packet, obviously I should be seeing what? SYN packet, then SYNAC and acknowledge. This is how it works. Now, you can either do it in the last step, or to make it much simpler, I'll open Wireshark. Before turning it on, I'll give this filter command first and then turn on Wireshark and then visit the site. So I'm not going to see all the 25,000 packets. Instead, I'm going to see only the packets captured by the server. So let me turn on Wireshark here. Wireshark. So to find the IP address of my server, so which website we are going to visit, we'll try to visit. Okay, let me see if I can visit. Can you name any one website? We'll visit google.com. Not this. Ping. Not this. Okay. We'll try to visit indiamike.com. We have an IP address like this. Let me copy this IP address and I'm going to paste this in here, ip.addr equal to, and I'm giving this IP address and enter. Now, what I'll do is I'll go to my browser. I'll open my browser and I'll try to visit indiamike.com. indiamike.com. See if you are receiving any packets. In case if you are receiving any packets, that is perfectly fine. If you are not receiving, what would be the reason? We have pinged indiamike.com, and yes, we know IP address of indiamike.com is this 44.196. and we are trying to connect to the same site, but still there is no packet which is captured here. Why? Huh? Host is unreachable. That is okay. Host is unreachable, then the website should not open. Let us check this. If it opens or not. Is it capturing packets? Yes, it is capturing packets. We'll open this indiamike.com. It is loading. In case if there is no packet which is captured, I'll tell you the reason why. Because this is there for your assignment. And when you try the same for any website, and if you're not receiving any packets, don't be confused. This is because indiamike.com can have multiple servers. The server which responded to your ping can be this IP address, but the server which is responding to any web-based request can be a different IP address. So it is that in case if the server has multiple IP address, you can get this. Let me stop this. No packets captured. Yes, we know that. We'll go for the college obsession. College. Huh? G. JIT. JIT.ac.in. Okay. JIT.ac.in. Which college is this? Jansen's Institute of Technology. Okay. Karmatampati. Perfect. JIT. Okay, I've given this. Enter. Start capture. 163 is the IP address. Yes, that's the IP address. Let me go here again. Page is loading now. JIT.ac.in. Enter. Let's see if you're getting this. You're getting any packets. JIT.ac.in. JIT. JIT. Where are the SK? SKCAS.ac.in. Fine. So any packet which is transmitted to this should be captured here. SKS. I think SKS is opening. We'll try this. Ping SKCAS.ac.in. Perfect. Copy this. Excellent placement. Okay. We'll open one more Wireshark where we'll give IP dot ADDR equal to, and this, and let us capture this Wi-Fi traffic here. Oh my God. 148 dot. Okay. Wireshark. This is not capturing. This has captured something. Let us stop this. Stop this. If you can see here the different flags which is transmitted. We have SYN, we have acknowledge, we have SYNAC, we have acknowledge. Let us try to find out what happened here. Wireshark is not responding. So you have to analyze packets like this. You can capture and you can see what packet went out of your computer what packet your computer has received, and you can also see the flags which has been transmitted. And as I said, my computer here, what is the IP address of my computer? The IP address of my computer is this 192.168.1.101, and the IP address of Sri Krishna College of Arts and Science is this, fine. And the intermediary packets, let us leave that, I'll explain that later. But when you look at this, the reply from 148 from Krishna College to my IP address is what? SYNAC. And if you scroll down a little, we'll have from my computer to Krishna College, from my computer 192.168.1.101 to Krishna College server, you have got acknowledge. Usually what happens is you won't get packets with intermediary packets like this. Since our internet was slow, it has made multiple accounts to send and receive packets. Or else what will happen? We'll have a SYN packet here, SYNAC here, and acknowledge here. Or one more packet. That's it. Fine. So this is how you can see, you can check how TCP three-way handshake happens. Not only this, we'll also go for one more thing here. Let us close all the windows. Zoom is capturing intense amount of traffic here. Okay. Next, to capture TCP three-way handshake is perfectly fine. Next is what? We'll capture username and password. Username and password for any HTTP website. HTTPS is going to be a little complicated. So we'll just look into HTTP website. So HTTP website, I'm going to log in. But before I log in, let us sort out this Wireshark. Close. Wireshark. Task manager. Yes. Okay. Yes, and I'll also share you the attendance form in the chat box. So username, password. So again, we are going to follow the same procedure, whatever we have followed here. We are going to give the same IP address, but the filter command, we are going to give this filter command here. We are going to give http.request.method. http.request.method, which is going to filter out only HTTP packets. And let's see what happened. So I'll go here. So I'll start with this. I'll say http.request.method. Yes. And I'll try to open up a website here, which is a basic HTTP website. We will go for test PHP website here. Yes, this is a test website. Doesn't mean that it's a test website. You can bring it down with a DOS attack. It is used for testing purpose. To use it wisely. Now, let me capture the traffic. Now, when you look at this, I'm going for sign up. Sign up. So you have got what? You have got the get login page. You've got the login page here. This is the login page. And the username and password for this particular page is test and test. And then now what I do, I go for login. When I click login, it logs in. It logs in and you will get the post packet here. And our Wireshark is stuck with Zoom traffic, and I'll show you what happens. You'll get a post packet for login. And after you get the post packet for login, it is going to be very simple. You are either going to double click on the packet, or you right click and click follow TCP stream. You're going to see the username and password at the sessions layer. Sessions layer is where you'll get the HTTP form URL encoded field in the packet, and using that, we'll see that. I'll show you this. Wireshark. Never expected Wireshark to go like this. Okay, I think this is also gone. Go for task manager. We'll see what happened. Okay, just stop. Okay, one is done. Stop. Close this. Okay, now we are up to this. Okay, we'll see this. I'll show you how we can do this. Now, the third task is I told you whatever you are visiting with this site, or in case if you're making a WhatsApp call, if you're making a Zoom call, or whatever you do, that packet is also captured by Wireshark. Say you are sending an image to your friend via an email. Now, this also goes in the form of packet. Yes, it goes in the form of packet. And if I ask you, if I capture all these packets and if I analyze all these packets, will I be able to get the image back? It will be encrypted. Okay. But I'm just asking, is it possible to retrieve an image like this? Yes, it is possible. It is possible to retrieve an image or retrieve a document which you have sent. This is a never-ending story here. Wireshark will open one more. Wireshark. So we have a specific file called source. So let me open this. I'm going to open a file which I have, which is called in my desktop. I have this file called source.pcap. Yes, this source.pcap, it has got a file called recipe. This source.pcap, this has got a file which is called recipe.docs. Recipe.docs. Now, what is our task? Our task is to find out this recipe.docs. We have to extract this file from this Wireshark traffic. So the first thing what we can do is you can use filter commands. That is okay. But I'll show you a different method here. You can either go for the search icon here, search, or you can go to edit. You can go for find packet. Both are same. Go for this. And this is going to be packet bytes. I'm going to search in packet bytes. And I'm going to search in the form of a string. I'm going to look for a file called recipe. Recipe, and let me click on find. Find recipe. Recipe, find. Do you have recipe here? Yes, but that is not a document file. We'll click on find again. Do you have recipe here? No. Click on find. Now, if you look at this, what do we have here? We have recipe.docs. Yes, we have recipe.docs. Now, what I'm going to do here is, this is from 192, 168, 1.158 to 159, from one computer to another computer. Right click on this. I'm going to follow TCP stream. Follow TCP stream. Now, what you have got this, and you have got this. This seems to be like recipe. Now, what you can do is you can filter out. When you look at the bottom, of this, you can filter out the packets which you have transferred from your computer to 158 to 159. You can filter out packets like this. So I'm going to click this, or if you want to see the packets received from that computer, you can click the down icon here. So I'm going to go for the first one. If I go for the first one, I have something like this, which, as you said, it is encrypted. We are not able to see this. Yes, very obvious. So now what happens is, I'm going to save this as show data as, I'm going to save it as raw. So this is going to be a raw data, and I'm going to save this file. Let me save this file as desktop. I'll save it as 1.docs. I can save it like this. Let me close this. Let me go to my desktop. 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 Okay, let us go from here. Let us go to desktop. If you look at this, we have one.docs. Yes. If I try to open this, click on yes. Now, if you see, this is the recipe file which has been transmitted. Yes. If it's an image file, if it is a file of different format, you can extract any sort of information like this. The only problem is in Wireshark, you will have to analyze each and every packet like this. We have an alternate tool, which is called network miner. Okay, let's stop this. I'll tell you about the alternate tool here. But before that, you stop this. About the username and password. This was a get packet, login, and this is the post packet. Now, this is the packet which will have username, password, two different methods. Double click on this. Switch network, TCP header. And if you look at HTTP protocol, you will have post packet, which website you have posted. Now, if you look at HTML form, you are encoded the username and password, what you have typed. Yes. And right click, go for follow TCP stream. And in follow TCP stream, you will have what? You will have the packet. As I said, red is from your computer to the server. So the username and password will be in red. So if we scroll down, you can look at the username and password, what you have saved here. Yes, as simple as it. And let us close Wireshark. Great. Alternative tool for analyzing all these packets. Yes, Wireshark is good, but when you look into a tool like we have network miner, this is a specific tool, network miner, which is free of cost. You can download from internet. Open this tool called network miner, run. I'm going to run this tool called network miner and see how simple it is going to be when extracting contents of any file. Network miner. Network miner run. You just have to give the PCAP file as an input. If you give PCAP file as an input, what will happen? It is automatically going to analyze all these files. And it is going to give you different details like this. Let me go here before it opens. Network. Network miner is going to give you, it's a single page tool, so it's very easy to use. Okay, go to file and open the PCAP file. Now, if you look at the tabs here, any files which is present inside the PCAP, it will be present here. Any images, it will be automatically extracted. Messages, and in credentials, you will have usernames and password. So you'll have all these segregated like this. It's going to be a very simple tool, but for analysis and categorizing the different aspects of Wireshark, it is going to help you. Yes. So when it comes to network security, obviously, traffic is also one important aspect which we have to cover. And that is the reason we have covered network traffic in the subject of network security, right? So you also have Splunk, which can be used in network security. This is going to be a log analyzer. And in network security, you have registry analysis. You have file analysis. Network security is an intense topic where it has multiple domains. Registry, file analysis, you have signature analysis. And you have Windows and Linux based, system based analysis, which all comes under network security. So, and again, when it comes to devices, you have firewall, you have IDS, you have IPS, all these devices to be in place. So 5 days, we wanted to make sure that, since I told you this is a mixed crowd, we have people who are from very basic, and we have people who are intermediate, and we have people who already have enough knowledge. So we wanted to create a syllabus which is common for everyone and which you can get benefited from. And that is why we are framed like this. And today's assignment. Yes, I'll have to give this today's assignment. Assignment, you'll have to capture TCP three-way handshake of any packet in Wireshark, of any website using Wireshark, and you'll have to capture username and password, and you'll have to submit the screenshot of the same. Yes, and again, network security, cyber security is a wonderful domain which has a very good scope for the next 30-40 years, I can say. And in case if you want to contact me, or if you want to reach me out for any sort of help regarding cyber security or ethical hacking or anything, you can go. I'm available in LinkedIn, Instagram. You can follow me there, and you can reach me out. And yes, probably this might help you. Please come up with genuine queries, not any illegal stuffs like hacking an Instagram account, Facebook account, not that. Any genuine queries of how to create your resume, what you will have to add in your resume, and how to apply for jobs or any sort of things, yes, you can contact us for sure. Yes, and you can also contact us for any training needs which you have. Yes, I hope this 5 days of training was useful for you, and I hope you to meet in another training like this. Thanks a lot. Thank you. ஏதாவது டவுட் இருந்தா சொல்றேன். Yeah, doubt. Certificate